Dr. Samadhan Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Today we are going to start unit number 4, Laplace transform. Before going to start Laplace transform, first we will see what are the applications of the Laplace transform. So in mathematics, when you are going to solve higher order differential equation, so there we will use Laplace transform to reduce that higher order differential equation in a simple polynomial form. Second application is in physics. We can also use Laplace transform in electronics, circuit problems as well as electrical problems to find the current. We will use again their Laplace transform. There are so many applications of Laplace transform around us also. Okay, now we will see how the Laplace transform is formed. Okay, so we will see the introduction part about the Laplace transform, how the Laplace transform term is formed. Okay, so we will see some basics. In differentiation, generally we use capital letter D as a differentiable operator. In differentiation, we always use capital D is a differentiable operator. If we apply this differentiable operator on a sum of function f of x, where f of x is any function, then this term can be written as, if we apply D operator on a sum function f of x, then this term can be written as f dash of x. So which is called as a transformation of the function. Okay. Now similarly in integration, we always use capital letter I for integration operator. Capital letter I integration operator, and if we suppose we apply integration operator on a sum function f of x, then this term can be written as, that is integral f of x dx. So which is also called as a integration transform. So similarly in Laplace transform, Laplace transform. Okay, so again here we use capital letter as a Laplace operator, and let us suppose that f of t be any given function, then this term can be written as f of s. Okay, so if we apply letter L on function f of t, then this term can be transformed in f of s. Similarly in Laplace transformation is also a kind of transformation. If we apply Laplace transform, if we apply L on a some function f of t, then it will reduce another form, that is f of s. So here L is a Laplace operator, f of t is any function. So if we apply L on this function, then it will produce another function, that is f of s, which is called as a Laplace transform. So if you observe from differentiation transform, integration transform, and Laplace transform. Okay, so we can say that if we apply some operator on some function, then it will produce another function. Okay, so these are some examples of the Laplace transform. Now, so these are some Laplace transform of some elementary functions. So there are 8 formulas. So by using this formula, we can solve the problems of Laplace transform. Okay, so dear student, you have to remember one thing of last formula, that is Laplace t to the power n equal to n factorial upon s to the power n plus 1. We can use formula when n equal to 0, 1, 2, 3, or or this formula can be used. Laplace transform of t to the power n equal to gamma of n plus 1 upon s to the power n plus 1. Okay, so when we use this formula, if the n is in the form of fraction form, this may be positive or negative, so that case we will use this formula. And here if the n is whole number 0 1 2 3 and so on, so that case we will use this formula. So you have to remember one thing here. Okay, so these are the very most important formulas. When you are going to solve the problems, we will use this formula. Okay, so you have to read it carefully. Okay, so we will use this formula to solve the problems. Okay, so we have seen some applications of Laplace transform. Okay, then we have seen the formation of Laplace transform. transform का कैसा form करते हैं. Then we have seen definition of Laplace transform and inverse Laplace transform. And finally we have seen Laplace transform of some elementary function. Okay, so we have seen 8 to 9 elementary functions of a Laplace transform. Okay, so in next lecture we will see the proof of these elementary functions one by one. Okay, so thank you very much for watching these videos. Thank you very much.